Smartphone overuse is a major social problem that affects individuals' physical health, mental well-being, and social wellness. There are already many intervention techniques to help reduce phone usage by informing users about their usage statistics, showing notifications, or restricting access to apps. These methods intervene with users based on predefined simple criteria, such as predetermined times or intervals after reaching the daily app or device usage limit. However, these techniques are suboptimal because they do not consider specific context or variability of human behavior. In mobile health, just-in-time adaptive interventions, JITAI, has been introduced as a promising technique that provides the right amount of support at opportune moments based on users' context. Traditional JITAI systems incorporate predefined rules to determine the delivery time or content. Recently, there has been work leveraging AI to deliver interventions. Moreover, in a human AI loop setup, users can offer feedback to the model to enhance its intervention. However, there is very little work that explores empowering AI-based JITAI with a human-in-the-loop setup. Meanwhile, despite the accurate predictions with black box AI models, they often face challenges of interpretability and transparency. This gave rise to the recent advance of explainable AI to help users understand AI systems' decisions, thereby fostering user trust and collaboration with AI. But there is no prior work integrating XAI into JITAI-based smartphone intervention. To address these gaps, we design and implement Time2Stop, an intelligent, adaptive, and explainable JITAI system for smartphone overuse. Time2Stop consists of two major human AI loops. In the first loop, contextual and app usage data is sent to the cloud server, where the server extracts features, performs model inference, and generates explanations. Then, these model predictions and explanations are sent back to the user. If the prediction is overused, then an intervention window pops up. Meanwhile, users can also provide feedback to intervention. This leads to the second loop. The feedback is used to update the model. This adaptive model then provides more personalized predictions and explanations, evolving with users over time. We introduce our interface design step by step. We adopt a typing-based intervention mechanism, where users need to enter randomly generated digits. They can continue using the app after entering the correct digits. Then, with a simple button, we collect user feedback, which will be used for model updates. Lastly, we provide explanations based on feature importance. We highlight the feature categories that were important for prediction. If the user wants to see more details, they can click the button to see more. To assess the effectiveness of both adaptability and explainability, we designed 4 distinct intervention types. Control, a probabilistic baseline. Personalized, which uses a static machine learning model without updates or explanations. Adaptive without explanation, which adds the adaptive capability to the machine learning model. Finally, adaptive with explanation, which is also the complete version of Time2Stop. This approach further adds explanations on top of the adaptation. Only Time2Stop has the explanation section, and the interface for control, personalized, and adaptive without explanation is exactly the same. We conducted an 8-week field experiment with 71 users, with 2 weeks of data collection, 1 week break, 1 week baseline, and 4-week interventions. Our results showed that the adaptive interventions are more accurate and show higher receptivity compared to control and personalized baselines. In addition, adding explanations further enhanced accuracy and receptivity. We also observed that adaptive models had the highest positive slope, improving intervention receptivity over time. Meanwhile, from the app usage behavior perspective, adaptive models helped users to reduce the number of visits made to unproductive apps. Lastly, adaptive models all receive higher preference rankings and subjective ratings. Please find more details in our paper.